Hello everyone, I am Kumar Singh from BTech Department of Electrical Engineering EE1 and I am here to present you my presentation on transformer for the ELP project. What is a transformer? A transformer is a static device which is used to transfer electrical energy from one AC circuit to another AC circuit. Input and output from a transformer both are alternating quantities. Actually, electrical energy is generated and transmitted at an extremely high voltages. This voltage is to be then reduced to a lower level for its domestic and industrial use, which is done by using a transformer. In transformer, when the voltage level changes, the current level also changes. What is the principle involved in transformers? A simple transformer consists of two electrical conductors called the primary winding and the secondary winding. In transformers, the primary winding is connected to a single phase AC supply, due to which an AC current starts flowing through it. When an AC primary current flows through it, then it produces an alternating current in the core. Most of this changing flux get linked with the secondary winding through the core. Now, according to Faraday's law of electromagnetic induction, this varying flux will induce voltage into the secondary windings. As there is no electrical contact between the two windings, so an electrical energy gets transferred from primary to the secondary. Also, in all this process, voltage level changes, but frequency, that is the time period, remains same. Types of transformers. The transformer are of different types depending on the arrangement of the core and the winding. They can be of core type, shell type, and berry type. Also, the magnetic core of a transformer is a stack of thin silicon steel lamination about 0.35 mm thick for 50 Hz transformers. In order to reduce the eddy current losses, these laminations are insulated from one another by thin layers of varnish. Difference between core type and shell type transformers. The core type transformers has only one window, whereas the shell type transformers has two windows. In core type transformers, winding encircles the core, whereas the core encircles the winding in shell type transformers. In core type transformers, cylindrical windings are used, whereas in shell type transformers, sandwich type windings are used. The core type transformers are very easy to repair, whereas the shell type transformers are not so easy to repair. The core type transformers has better cooling since more surface is exposed to the atmosphere, whereas cooling is not so very effective in shell type transformers. Losses in transformers. There can be iron losses, copper losses, stray losses, or dielectric losses. The iron losses mainly occurs through the alternating flux within the transformer's core. Once this loss occurs within the core, then it is called core loss. The iron loss can be due to eddy current loss or hysteresis loss. The copper loss occurs because of the ohmic resistance in the windings of the transformer. That's why it is also called ohmic loss or resistive loss. The stray loss occurs in the transformer because of the occurrence of the leakage field. The dielectric loss are caused by the insulating material and insulation such as transformer's oil. It rarely occurs as compared to the core and copper loss. Applications of transformers. The transformers make it possible to convert electrical power from a generated voltage of about 11 kV to higher values of 400 kV, 500 kV, etc., thus permitting transmission of huge amounts of power along long distances. Also, at distribution points, transformers are used to reduce this high voltage to a safe value for use in homes, office, etc. In electric communication, circuit transformers are used for various purposes. Example, as an impedance transformation device to allow the maximum transfer of power from the input circuit to the output device. Transformers are also used for the measurement of current and voltage in single and three-phase system. They are also used for the measurement of power and energy. Now, I conclude my presentation. Thank you.